Okay, go ahead.
So this is our soil and vertebrate diversity. I'm Tracy.
I'm Clayton.
I'm Matt.
I'm Mike.
And a little bit of background that we discovered is new growths are similar to the old growths, but the old growths support more individuals and they usually have a higher diversity. Invertebrates that affect soil diversity can relate to earthworms, and they do activities like burrowing, casting, and dispersal, and they can cause chemical and biological makeup of soil. Habitat requirements of individuals suggest that certain species can't live in the new growth area because of the climate and habitat, but they can live in the old growth with no problem. And the old growth is overall usually more diverse than new growth. So the objectives that we had were first to explore various landscapes and growths in the Nature Center at Mount Union, and then we had to form the hypothesis in relation to biodiversity and use the Berlese funnel to test our hypothesis, and then examine diversity in invertebrates and classify them according to John Mayer's book. And finally we had to draw conclusions about the two growths, the old and the new, based on diversity and index for each one.
So our methods and materials, we took both of our samples from the old and the new, put them in our baggies, and we put them in our funnels with a hot lamp over top to make the invertebrates go down with a filter into the alcohol, and we can preserve them. Then we would petri dish, we put them in there, we took them out into another petri dish so we can sort them out and examine them better, and then we would classify them.
As far as our data gatherings go, this is the data for the new growth forest. As you can see, we have a high number in here, which we'll explain later, how it changes the H values. But for the new growth, the H value was 0.5865, which is far from the maximum of 1.43 that was calculated. And as the old growth compares to the new growth, this kind of supports our hypothesis in a way that the H value is closer to the H max value. So that means that there was more diversity in the old growth.
The new growth resulted in a large number of total organisms compared to the old growth. However, the order Arachnia contained is 16 out of 27 in the new growth organisms, displaying on the outline. Diversity index H for the old growth was 0.7748, was more precise according to the maximum 0.8451. While diversity index for new growth was low in comparison to the H max, displaying the outlier of Arachnia. The varying H values diversity index is most likely due to thicker organic layers, water availability, and moisture in the old growth forest. And the older leaf litter offers more nutrients to soil and vertebrates because of the quicker characteristics. In conclusion, the experiment conducted at the Nature Center is beneficial in understanding the physical characteristics of the various invertebrates. Overall, the invertebrates would be inclined to live in the old forest because conditions are more favorable than the new growth forest. And the experiment concluded that the old growth is more diverse than the new growth based on the calculations gathered, which supported our original hypothesis.
Any questions for them?